So for number 11, they want us to find at least 10 partial sums of the series, and then we graph both the sequence of terms and the sequence of partial sums. So what I've done is I've created this table here, where on the first column is just the index, right? We're summing up from 1 to 10. The second column is our sequence. So when we plug in 1 here, so that would be 1 divided by 1 squared plus 4, which is 1 over square root of 5. And then for 2, we have 2 divided by square root of 2 squared plus 4, so 2 divided by 8. And 3 divided by square root of 3 squared plus 4, so 3 divided by root 13, and so on and so forth, until the last term, which is 10 divided by square root of 10 squared plus 4, which is 10 divided by 104. So that's our ANs, but then our sequence of partial sums is going to be the sum of all our ANs, right? So the first one, well, we're just summing up 0.44721. That's no mystery. For the second one, we're summing up the 2 divided by root 8 to the first one, 1 divided by 2 root 5. And then that's going to give us our second sum. For the third one, we're summing up a1, a2, a3. For number 4, we're summing up a1, a2, a3, a4. For number 5, we're summing up the previous 4 with the fifth term, and so on and so forth. And so we're just summing up all of these from 1 to 10. And so it wants us to graph this. So let's go ahead and do that. Let's see. I'm going to have to clean this up a little bit. Okay. So it's going to be here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's the values, and this is our A1. So that's going to be n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this on our horizontal axis, that's going to be our n. And on our vertical axis, we're going to put both AN and SN. So I'm just going to color code it. We're going to first do, in yellow, we're going to do our AN. So for the first one, if n is equal to 1, our AN is going to be 0.447. So it's going to be about here, half. And then for A2, it's going to be 0.7, so like this. A3 is 0.8, so a little bit higher. And then A4, 0.89. So these are going to get all very, very close. 0.92, so even closer. 0.94, like this. 0.96, 0.97. Once more 0.97, and lastly 0.98. So I've drawn, I had to draw them really, really close to 1, right? Because they are, so you can't really differentiate them. And for our SN, this is going to be our SN, so that's going to be our sum. Well, the first one's still 0.444. The second one's going to be 1.15, so about here. The third is going to be 1.98. The fourth is going to be 2.88, so about here. The fifth is going to be 3.8, so like so. The fourth is going to be 4.75. Sorry, the sixth is going to be 4.75, so around here. The seventh is going to be 5.71, so 5.71. The eighth is going to be 6.68, so 6.68 here. The ninth is going to be 7.66, so 7.66. And lastly, the 10th is going to be 8.64, so 8.64 here. And so what we can see here is that the sum is going to get bigger and bigger and bigger, right? And the reason that it's going to get bigger is because AN, each individual term, as we can see, the limit of AN is 1, right? So what happens is, since the limit as n approaches infinity of AN, this is equal to 1. If we take that limit, we're going to find 1, and we can see it graphically. It means that the sum, whenever we increase our index by 1, the sum is going to increase by 1. So since we keep adding 1 and 1 and 1, or at least the limit as it tends to 1, our sum is going to increase forever and ever, right? And so we can say here that the limit as the limit of, let me correct that, Sn as n tends to infinity, this is going to be infinity. So Sn diverges. And that is it for number 11.